Okay, so for this fourth problem, we're going to go through and now consider some trig functions. And again, this undetermined coefficients only applies to sine and cosines because their derivatives replicate each other. But if you take functions like tangent and secant, those get ugly and terrible, and we don't ever want to use this method to try to solve those problems. It just simply won't work. So once again, the first step is to always solve the homogeneous problem. So in this case, it's y double prime plus 4 times y is equal to 0. That's just lambda squared plus 4 equals 0. So lambda equals plus or minus 2i. So our y1 of t is the cosine of 2t, and our y2 of t is our sine of 2t. All right, so once again, you should always check for linear independence of these two homogeneous solutions and your first forcing term, and you will notice that the cosine of 3t can never be created by adding constant multiples and sines and cosines of 2t. Trig functions just don't behave that way. So these are going to be linearly independent. All right, so the next step is to now find our particular solution. And again, we need to look at our forcing term to build that. So yp of t is going to have an unknown coefficient a times the cosine of 3t plus another unknown coefficient b times the sine of 3t. And then we need to take our first and second derivatives. So our first derivative is going to be a negative 3a sine of 3t. And then that's going to be plus a 3b cosine of 3t. Taking a second derivative and applying that chain rule again, we're going to have a negative 9a cosine of 3t minus a 9b sine of 3t. And now these will all be substituted into our original inhomogeneous equation, so we can match up coefficients and solve for the constants. So we now substitute in y double prime is that negative 9a cosine of 3t that we just found, minus the 9b sine of 3t that we just found. And then we're going to have a plus 4 times our particular solution y, which again is a cosine of 3t plus b sine of 3t. And then that is going to be equal to our cosine of 3t. We can now go ahead and multiply and combine like terms. So we first combine the cosines. We've got negative 9a of them plus 4a of them. 4a of them is going to make negative 5a of them. So we got negative 5a cosine of 3t. If we now look at our sines, we got negative 9b of them plus 4b of them is going to make negative 5b of them. And again, that must equal out to the forcing term, cosine of 3t. All right, so now we can match up our coefficients. And the first thing to do is look at our cosines. We've got negative 5a on one side, matching up with a 1 on the other side. So that says that negative 5a must be equal to 1. For the sines, we've got a negative 5b on the left, and we've got basically a 0 sine of 3t on the right-hand side. So that negative 5b must match up with 0. So we now know that our a is equal to a negative 1/5. And we know that our b is equal to 0. So our particular solution, yp of t, is just equal to negative 1/5 times the cosine of 3t. And then when we find our general solution, our y of t, that's going to have arbitrary constant c1 times the cosine of y1, which was cosine of 2t. And then we're going to have a plus c2 times the y2 solution, sine of 2t. And then we're going to have our minus 1/5 times the cosine of 3t. And just like before, you will notice that this cosine of 2t, the sine of 2t, and cosine of 3t are all linearly independent. So our general solution is the sum of the homogeneous solution and this particular solution.